This video is for IM2, day 52, problem number 1, where we're asked to find the range of this function. And essentially what this boils down to is practicing completing the square, and then just thinking about how once we complete the square and get it into vertex form, we can look at the graph and determine a range of values for y. So what I'm going to do is since I don't want to write f of x all the time, I'm going to change this a little bit just to make it a little more user-friendly. And actually, this is going to look more like what we were completing the square with earlier to put it into vertex form. So the first thing I'm going to do is get this ready to complete the square. So I need to add 1 to both sides. Then I need, the most important thing to remember about completing the square is you need this coefficient here before the x squared to be equal to 1. So in order to do that, I'm going to multiply both sides by 2/3. When I multiply the x squared term by 2/3, I'm just left with an x squared. And then I've got to multiply this, so I've got to have 6 times 2/3 x. Let's do a simplification step. So I can write 2/3 y plus 2/3. That's going to be equal to x squared plus, that's going to come out to be 4x. So completing the square, I'm ready to go. Forget about the left side for now, okay? When we're completing the square, we really just want to worry about this right now. What I want to do is take this term, the x term, divide it by 2, square it, and then add that to both sides. So take 4, divided by 2 makes 2, then square it. I'm going to, and let me do that in red, I'm going to add 4 to both sides. I'll just kind of sneak it in here, add 4. Why do I need to add it to both sides? So I don't break algebra. We can't just add things to one side of the equation or the other without doing it to the other side, all right? So now what I'm going to do, let's rewrite everything we've got here. So I've got 2/3 y plus 2/3 plus 4 is, now, the reason I added this 4 here was to complete the square, right? That's like the step in completing the square. So we want to write this as a perfect square. Whenever you're completing the square, that's what you should end up with. So I can factor this, let me get my pen. I can factor this into x plus 2 quantity squared. I did that by design, right? I added that 4 by design so I could get down to this. So you should always get a perfect square. So let's simplify the left side. We're almost done. 2/3 y plus, I'm going to turn 4 into 12/3, so that's going to give me 14/3. That's going to be x plus 2 squared. I'll continue on the right side here. So then I'm going to, let's subtract, now I need to solve for y to get it into vertex form. So I'm going to subtract 14/3 from both sides, and that's going to give me 2/3 y is x plus 2 squared minus 14 over 3. Now, to get rid of this last piece, right, remember I'm solving for y, I need to multiply by 3/2. So let's multiply both sides by 3/2. That's going to leave me y. I need to multiply this by 3/2. Then I need to multiply this last part by 3/2. So I only have one step left, right? I just need to simplify this last piece. And you'll notice I'm multiplying fractions here. The numerator and denominator can cancel, so I get 14 over 2, which can be reduced to 7. So for my last step, y equals 3/2 x plus 2 squared minus 7. So my vertex is going to end up being -2, -7. All right, remember that always the x is going to be the opposite sign, right? Because it's in the parentheses. I could have added the 7 to the other side, and that's really what we called vertex form when we talked about it previously. We had the 7 over there, and remember, we did opposite of both. But if the y is on this side, you just take it as it is, and that's going to be the right vertex. So I've still got some room up here, so let's draw just a quick sketch of this so we can talk about the range, which is really what we were getting at. So I'll plot the vertex, -2, -7, somewhere around here. Doesn't have to be perfect. Remember, our vertex form also tells us if we're opening up or down. So if there's a negative right here, we're going to open down. There's not, so we know we're opening upward. This is 1.5, so it's bigger than 1. So that's going to make it a little skinnier, but we don't really care about that too much. So we're going to just make a parabola. All right. And I know that this point is -2, -7. So, range, what's the range? Well, the range is the possible y values that we can get out of this function, right? So it looks like we can get a lot of y values up here. This is going to go off to infinity. But I can't go down below 7, right? No matter what I put in, I'm not going to get lower than -7. So to write our range, and right now we're not really getting specific about how we write it. Just write range. You could do a colon, or you could just do R. Is just going to be y must be bigger than or equal to -7. And for now, that's all we need to do.